Okay, so today you're going to learn about mass mole thing conversions. Now, the relative atomic mass scale makes it possible to know how many atoms of an element are present in a sample of the element with a measurable mass. Now, three very important concepts provide the basis for relating masses in grams to numbers of atoms. The first one is a mole. Now, a mole is the amount of substance that contains as many particles as there are atoms. Now, mole is going to be your best friend from now on throughout the rest of chemistry. And mole is abbreviated to MOL. Our next concept is Avogadro's number. It's not avocado, it's Avogadro's number. And his number is 6.022 times 10 to the 23rd. And that number means it's the number of particles in exactly 1 mole of a pure substance. The units for Avogadro's numbers is molecules, atoms, or particles. And our next concept is molar mass. Now, molar mass is the mass of 1 mole of a pure substance, so either an element or a compound. And it's the sum of all of the atoms' atomic masses. And it's abbreviated to capital M, capital M. And the unit for molar mass is grams dash mole, grams per mole. So here's a picture of a mole island map. Now this is going to be underneath essential materials on your Google Classroom. So Thien Island is where all your particles, molecules, atoms will be. Your mole is where your moles will be, and your mass is where your grams will be. So if you're going from Thien to mole island, when you're going to convert from particles to moles, molecules to moles, atoms to moles, you're going to do 1 mole over Avogadro's number. Now, if you're going from moles to Thien's island, so if you're going from moles to molecules, moles to atoms, or moles to particles, it's going to be Avogadro's number over 1 mole. So a couple notes. Note number one is answers should be in the same number of significant figures with what you started with. So we're going to be doing a lot of sig fig rounding in these problems. Also, answers must have a unit and compound or element following the number. Never leave your numbers naked.
Okay, so let's do some examples of these conversions. So here we have how many moles are in 2 times 10 to the 22nd atoms of magnesium. So we gotta figure out what are we given in this problem. Well, we are given the 2 times 10 to the 22nd atoms. And what we need to try to find is how many moles. So we gotta find the number of moles. So we gotta refer back to that mole island sheet, because that mole island sheet tells you what goes on the top, what goes on the bottom. So what we're given is atoms. We know atoms is Thien's, so we're gonna start at Thien's island. And we need to find moles. And we know moles is mole island. So we're going from Thien's island to mole's island. And as you can see, this is the type of what goes on the top and what goes on the bottom that you can see on the screen right now. So let's go ahead and start this calculation. So we always start out with what we're given. And we got magnesium, and the atomic symbol of magnesium is capital M, lowercase g. We always got to do the times in the line. So we know that on the bottom, looking on the screen with the mole island sheet, is on the bottom is going to be Avogadro's number. '23rd, and then atoms, And what goes on the top is that 1 mole. So let's go ahead and calculate that. When you go ahead and plug that into your calculator, again, to put in significant figures, scientific notations, go ahead and look on those videos depending on the calculator underneath the essential materials section on the classroom. So when you do this, you are going to get 0.0332 moles. Remember, we got to do your units, and we have to include our element or compound of Mg. Now you're not done, because remember, we got to see if we have to round that to the proper number of sig figs. We got to figure out how many sig figs we started with. So we have 2 times 10 to the 22nd. Well, we only have 1 sig fig. So we're going to round our number to the first sig fig. These zeros are not significant. Our first sig fig is 3. And this 3 tells me the 3 stays the same. So your actual answer that you are going to give me for full points is 0.03 moles of Mg. Okay, now we got how many molecules are in 2 moles of C6H12O6. Now we got to figure out what we're given. Well, we are given 2 moles. And what we need to try to find is our molecules. So for us to figure out that conversion looking at Mole Island, if we're given moles, we know that we're starting at Mole Island. And if we're given molecules, we're starting at Thanes Island. We're ending in Thanes Island. So we're going from Mole Island to Thane Island. So let's go ahead and start calculating this. Now, we start with our 2 moles of our C6H12O6 times the line. And if you look on the screen, if we're going from moles to Thanes, on the top, looking at our Mole Island sheet, on the top it tells me Avogadro's number needs to go on the top. And on the bottom is our 1 mole. So if you go ahead and plug that into your calculator, again, refer to those essential materials videos of how to do scientific notation on the calculator. You're going to get 1.2044 times 10 to the 24th molecules of C6H12O6. Now, if you give me that answer, you're not going to get full points, and you actually might get the whole question wrong, because again, we got to do sig figs. Sig figs. So, we have 2 moles. 2 only has 1 sig fig, so we got to round our answer to 1 sig fig. Our 2 tells me the 1 stays the same, so your answer you're going to give me is 1 times 10 to 24 molecules of C6H12O6. And that is your answer. Okay, now we have how many moles are in 2,500 atoms of tin. So again, we got to figure out what we're given. Well, we're given 2,500 atoms. And we are trying to find the number of moles, okay? So we got to look at our Mole Island sheet. Where are we starting at? Where are we going to? Well, if we're given atoms, we know that we're starting at Thanes. And we need to find moles, so we know we're going to end in moles at Mole Island, okay? So let's go ahead and start calculating. We always start out with what we're given. Our 2,500 atoms of tin. The atomic symbol of tin is Sn, capital S, lowercase n. And if you look on the mole island sheet, we have a picture of it on the screen right now. And it's going to tell you what goes on the top, what goes on the bottom. Since we're going from things to mole island, what's on the top is 1 mole, and on the bottom is Avogadro's number. So, you plug that into the calculator. Remember, multiply the top, divide the bottom. You are going to get 4.151 times 10 to the negative 21 moles of Sn. Now you're not done, because if you give me this answer, you're going to probably get the whole problem wrong, because we got to do sig figs. So we start off with 2,500. We know the 2 and the 5 are significant. These zeros are not significant because there's no decimal point in that number. There's a decimal point somewhere in the number, those zeros will be significant. Since there's no decimal point, those zeros are not significant, so this number only has 2 sig figs. So we got to round our answer to 2 sig figs. This 5 tells me the 1 goes up, so your actual answer is 4.2 times 10 to the negative 21 moles of Sn. All right, now we have how many atoms are there in 2.75 moles of aluminum. We got to figure out what we're given, what we need to find. Well, what we're given is our 2.75 moles, and what we're trying to find is our atoms, number of atoms. So we got to figure out what island am I starting with and what island am I going to end with. If we're given moles, we know we start at mole island. And if we're given atoms, we start at Thames Island. So let's go ahead and start calculating. We always write out what we're given, which is our 2.75 moles of aluminum. Atomic symbol of aluminum is capital A, lowercase l. And looking at your mole island sheet, we got a picture of it on the screen. Since we're going from moles to thanes, our mole island tells me that 1 mole goes on the bottom and our Avogadro's number goes on the top. And then you just go ahead and you solve it, multiply the top, divide the bottom. And you're going to get 1.656 times 10 to the 24 atoms of aluminum. But again, if you give me this answer, you're going to get the problem wrong, because we got to do sig figs. So 2.75, that number has 3 sig figs. So we got to round our answer to 3 sig figs. This 6 tells me the 5 goes up. So your final answer for this problem is 1.66 times 10 to the 24 atoms of aluminum.
Okay, so go ahead and do this problem on your own. And here's your answer. Go ahead and do this problem on your own. Here's your answer. Okay, so now let's go ahead and talk about conversions between mole and mass, mass to moles. So if we're going from moles to mass, so that means if we're going from moles to grams, it's going to be the molar mass over 1 mole. And if you're going from mass to moles, so grams to moles, it's going to be 1 mole over the molar mass.
Okay, so before we start doing the mass to mole conversions, we need to figure out how do we calculate molar mass? Well, we just talked about it before that the molar mass is the sum of all the atomic masses of each element in the compound. So let's go ahead and practice that. So we got calculate the molar mass of the following. So our first compound we have is K3PO4. This is potassium phosphate. You're going to learn how to name these. That's the last thing you're going to learn in this trimester. So don't worry about naming them right now. So what I like to do with these molar masses is take one element at a time. Okay, so our first element is K. K is potassium. So looking that up on the periodic table, you get this, it's on the screen. So our atomic mass, we got to round them to the second decimal place. So when you do that for potassium, you get 39.1. And we have 3 of them in the compound, so we're going to multiply that atomic mass by 3. And again, we're taking the sum, so we've got to add. Our next element is P, which is phosphorus. If you look that on the periodic table and round to that molar mass to the second decimal place, you are going to get 39 point, not 39, sorry. You're going to get 30.97. And we only have 1 phosphorus in the compound, so we're going to multiply that atomic mass by 1. Again, continuing on, our last element we have is O. O represents oxygen. So looking that up on the periodic table and rounding that atomic mass to the second decimal place, the atomic mass of oxygen is 16, and we have 4 of them in the compound, so we're going to multiply that 16 by 4. When you go ahead and calculate all that up on your calculator, your final answer is going to be 212.27. And the unit for molar mass, remember, was grams per mole. So don't forget your units for your molar mass. Is grams/mole, grams per mole. So let's go ahead and do the next one. Again, we're going to take one element at a time, looking up on the periodic table what their atomic mass is, rounding it to the second decimal place, and multiplying it by how many there are in the compound. So we got MgOH2. This is magnesium hydroxide. So our first element is magnesium. If you look on the periodic table, do all the rounding, magnesium's atomic mass is 24.31. And we only have 1 of them in the compound, so we're going to multiply the 24.31 times 1. Remember, you got to take the sum. Now, we only have 1 oxygen here, but we have a 2 outside the parentheses. Whenever we have a 2 outside of the parentheses, you are going to distribute that 2 to both elements. And you're going to multiply it. So now we have 2 oxygens. So our atomic mass for oxygen is 16, and we're going to multiply that by 2 since we have 2 of them. And then our next element is hydrogen. Looking on the periodic table, that atomic mass of hydrogen is 1.01. We have 2 of them in the compound, so we're going to multiply that by 2. And then go ahead and plug that into your calculator, and you are going to get 399.4 0.91 grams per mole. Don't forget those units. All right, let's go ahead and do the last one. Remember, we'll do one element at a time. So this is iron 3 sulfate. So we got to start with iron. Iron's atomic mass is, when you look on the periodic table, is 55.85. We have 2 of them in the compound, so we're going to multiply that by 2. Our next element is sulfur, but again, we got this 3 outside the parentheses. So we got to distribute this 3. So we had 1 sulfur, but since we distribute the 3, 1 times 3 is 3, so now we have 3 sulfurs. On the periodic table, sulfur's atomic mass is 32.07. We'll multiply that by 3 since there's 3 of them. And then we have our last element is oxygen. Atomic mass of oxygen is 16. And we distribute that 3, so 3 times 4 is 12. So we've got 12 total oxygens. And then when you plug that all in your calculator, actually, sorry guys, the MgOH2, the molar mass is actually 82.64 grams per mole. And then when you calculate the Fe2SO4 that atomic mass is 399.91 grams per mole.
Okay, go ahead and do this problem on your own. And here's your answer. And go ahead and do this problem on your own. And here's your answer. Okay, so now that we know how to do molar masses and whatnot for these types of problems, just another note again, answers should be in the same number of significant figures with what you started with. And also, answers must have a unit and compound or element following the number. Never leave your numbers naked.
Okay, so let's do some problems of doing some mole mass, mole conversions. So this problem, we have how many moles are in 5.00 grams of CaCl2. Again, with these types of problems, we've got to figure out what we're given and what we're going to. So we have 5.00 grams is what we're given. And what we're trying to find is, again, our moles. So looking at our mole islands, you've got to figure out what island am I starting with, what island am I ending in? Well, if we're given grams, we're starting at mass. And if we need to find moles, we want to end at mole island. So let's go. So with all these problems, we need to know the mole, with all the mass mole conversions, we need to know the molar mass of the compound associated in the problem. So we have a compound of CaCl2, so let's go ahead and find that molar mass of that compound. So our atomic mass, looking on the periodic table for calcium, is 40.08. And we have only 1 of them in the compound, so we're going to multiply that number by 1. And then our atomic number for chlorine, Cl, that's on the periodic table, is 35.45. And we have 2 of them in the compound, so we're going to multiply that number by 2. And when you plug all that in your calculator, you're going to get 110.98 grams per mole. So let's go ahead and start calculating. We always write out what we're given. We're given 5.00 grams of CaCl2. So let's go ahead and then let's go ahead and look at the mole island sheet. Since we're going from mass to moles, on your mole island sheet it tells you that your molar mass goes on the bottom, so that's what we just calculated at 110.98 grams. And on the top, it tells us it's 1 mole. So again, we multiply the top, divide the bottom, and when you do that on your calculator, you are going to get 0.04505. Again, our unit is moles, and the compound is our CaCl2. So remember, we still got to do our sig figs, round to our sig figs. So we have 5.00. Our 5 is significant. Also, these zeros are significant because they're after the 5 and there's a decimal point. So we have a total of 3 sig figs in this problem. So we got to round our answer to 3 sig figs. These zeros are not significant, so our first significant number is 4, 5, and then 0, right? That's a sandwiched. And this 5 tells me the 0 goes up. So our answer is 0.0451 moles of CaCl2. All right, now I have a problem that says how many grams are in 2.25 moles of FeCl3. So in these types of problems, again, we got to figure out what are we given and what are we trying to find. So we are given 2.25 moles, and what we're trying to find is grams. So if I am given moles, I know I got to start at mole island on our mole island sheet. And if I need grams, we're ending in mass island, which is we're ending in mass island because we want grams. Again, these types of problems, we always got to find the molar mass of that compound. The compound in this problem is FeCl3. So let's go ahead and find that molar mass. On the periodic table, our atomic mass of Fe is 55.85. And we have one of them in the compound, so we're going to multiply that atomic mass by 1. And then on the periodic table, our atomic mass for chlorine is 35.45. And we have 3 chlorines in this compound, so we'll multiply this atomic mass by 3. When you plug that into your calculator, you will get 162.2 grams per mole. Now let's go ahead and calculate this problem. We always start out with what we're given. What we're given is our 2.25 moles of FeCl3. Now, looking on our mole island sheet, since we're going from moles to mass, our mole island sheet tells us that our 1 mole goes on the bottom and the molar mass goes on the top. What we just calculated the molar mass, we got 162.2 grams. You'll go ahead and calculate that on your periodic table, multiply the top, divide the bottom, and what you will get is 364.95. Remember your unit and your compound. And again, you're not done. We got to do sig figs. So we started with 3 sig figs, since 2.25 has 3 sig figs. So we got to round our answer to 3 sig figs. Highlight our first 4. The 9 tells me the 4 goes up. So your answer is 365 grams of FeCl3. So now we have, alrighty, So now we have how many moles are in 20 grams of CO2. So again, with these types of problems, we got to figure out what we're given. We're given 20 grams, and what we need to try to find is our moles. Now, for these types of problems, we got to figure out what island are we starting at and what island are we ending at. Since we're given grams, we're starting at mass island. And since we need to find moles, we're ending in mole island. And also, if we're associating mass in some way, shape, or form, we need to find that molar mass of that compound. This compound that we're talking about is CO2 in the problem. Let's go ahead and find that molar mass. So the molar mass of CO2, we got the atomic mass of carbon on the periodic table is 12.01. We have one of them in the compound, so we'll multiply that by 1. And then looking at our periodic table, the atomic mass of oxygen is 16. And we have 2 of them in the compound. And then we do the calculation on your calculator, and you're going to get 18.02 grams per mole. So now we're ready to go ahead and do our conversion calculation. We always write out what we're given. We're given 20 grams of CO2. Looking at your mole island sheet, since we're going from mass to moles, and your mole island sheet tells us that 1 mole goes on the top, and our molar mass goes on the bottom, what we just calculated. And then you're going to go ahead and calculate it. So you multiply the top, divide the bottom, and when you do that, you get 1.1099. Remember your unit, we want moles, so we enter in moles. And don't forget your compound, CO2. Now you're not done yet, because we've got to do sig figs. We only have 1 sig fig in 20. There's no decimal point or sandwiching going on. So we have 1 sig fig. So we got to round our answer to 1 sig fig. This one tells me the 1 stays the same, so your final answer is 1 mole of CO2. Now we have how many grams are in 1.87 moles of AlCl3. We got to figure out what we're given and what we're trying to find. We are given 1.87 moles, and we're trying to find our grams. We got to figure out what island are we starting at and what island are we ending at. Since we're starting with the moles, we know that we're starting at mole island. And we're ending in grams, so we're ending in mass island. Anything that is associated with mass, we need to use the molar mass. So let's go ahead and find the molar mass of our compound of AlCl3. So on the periodic table, our atomic mass of aluminum is 26.98. We only have 1 aluminum in the compound, so we'll multiply that number by 1. Our atomic mass of chlorine in the periodic table is 35.45. And we have 3 of them in the compound, so we got to multiply that number by 3. Plugging that into your calculator, you get 133.33 grams per mole. So now we're ready to do our conversion calculation. Again, we always start out with what we're given. We're given 1.87 moles of aluminum chloride, AlCl3. Now, looking at your mole island sheet, we know we're going from moles to mass. We're going from moles to mass. So our mole island sheet tells us that 1 mole is on the bottom and our molar mass is on the top. So now we're good to calculate, multiply the top, divide the bottom, and when you do that, you get 249.3271. Unit is grams, and our compound is aluminum chloride, AlCl3. You're not done yet because we got to do sig figs. So 1.87 has 3 sig figs. So we got to round our answer to 3 sig figs. This 3 tells me the 9 stays the same. So your final answer is 249 grams of aluminum chloride.
Okay, go ahead and do this problem on your own. And here's your answer. And go ahead and do this problem on your own. And here's your answer. All right, that's all I got. Thank you so much.